Hello everyone. Today I am going to explain multivariable functions. So what do you mean by a function of several variables? So what is the need of this that function of several variables? Sometimes we know that the function depends on more than one variable. For example, in case of this right circular cylinder, if we want to find out the volume of this cylinder, we know that this volume depends on two variables. One is r and another is the height, means radius and height, right? So this v, it depends on two independent variables r and h. So it is a function of two variables r and h, where r and h, they are independent to each other, right? But this v, it depends on r and h. So this v is a function of two variables r and h. So if we need to find out the volume of the right circular cylinder, we require two independent variables r and h. We require the values of these two. When we put these values over here, we get the volume of this right circular cylinder. The same way, if you want to find out the height of a paraboloid, right? If you want to find out the height of this paraboloid, so this paraboloid, this height is in the terms of x square plus y square. So this depends on two variables x and y. Let's suppose this z denotes the height of this paraboloid. This height depends on two independent variables x and y. So it comes out in the terms of x and y. So it's a function of two variables x and y, right? So what is a function of several variables? Now just see the definition of it. What is the function of several variables? Suppose we have D, which is a set of n tuples of real numbers, say x1, x2 till up to xn. Then a real valued function f defined on this domain D is a rule that assigns a real number like w. It's a function of these n independent variables, right? And when we substitute these values, we will get a real number which is denoted by w. So w is a real valued function defined on the domain set D, which is having n independent variables. So that is called n tuples of real numbers. Then this w is a real valued function which depends on these n independent variables. So we say that this function is a function of n independent variables. So here f is a function of n independent variables, right? Here these x1, x2 till up to xn, they are the input variables, and this w, this is said to be the output variable which depends on this n independent variable. For example, in a case of a volume of a right circular cylinder, right, since it is pi r square s, so it depends on two independent variables, that is r and h. And when you substitute these values, you will get a real value with v, which is a output variable, right? It's the output function which depends on these two independent variables, input functions. So when we substitute these values, we will get the volume of the volume of the right circular cylinder. So in this way, function of more than one variable, independent variable, is defined. Okay. So we can find out the value of the function if the function is given to us. Let's suppose our function is x square plus y square plus z square square root. So it depends on three variables. So it's a function of three independent variables. And let's suppose we have to find out this value at 3 comma 0 comma 4. So what will the value of this function at 3 comma 0 comma 4? Its value will be 9 plus 0 plus 16, which is 25 square root. That means 5, right? So what is basically the domain set? So here we are having a function which depends on n independent variables, means domain set to a real value. So we get, after substituting these value, we get a real function, right? So domain set is what set where the function is defined, right? The function defined on this domain set, means domain set are those numbers which where we cannot lead to the complex numbers or division by 0. For example, if you consider a function of two variables, let's suppose the function is square root of y minus x square. Now just see, if your y is strictly less than x square, then this value will be negative. So we get a complex number. So this is not a member of domain. So we require real valued function. So this should be positive, right? So what are the domain set for this function? What are the domain values? Means what are the values of x, y and y for which this function is defined. So here this function is defined, means the domain set is those values of x and y belonging to the real numbers, right? Such that your x square is strictly less than or equal to y. Your y should be greater than equals to x square. So you require all those real numbers such that x square is less than equal to y. So this is your domain set. Only then we will get the real values. Similarly, if you see one more example, let's suppose the function of two variables is given to you. This is 1 over x into y. So what is the domain set here? So domain set is those x, y belonging to the real numbers such that their product is non-zero. So it is a r cross r except 0, right? Except all those values where x, y, the product of x, y is 0. So it is a set of all those real numbers such that x into y is 0, right? So this is the domain set. So domain set is what? Domain set is that set where the function is defined. So here we are talking about the real valued function. So it should be defined for real values. So it means the values comes out to be real. Range set in case of range. So what is a range set? Range set is a set. It is a image set, you can say, of the domain, right? So f over this domain is the range set. Means when you put the values of the domain in a function, you get some values, you get some images of the function. So if you collect all these images, that set is said to be the range set. And this is said to be the codomain, which in this case is the codomain. Here it is a set of real numbers, right? So f is a mapping defined on a domain set to some set of real number. Then this is domain set, this is codomain set, and the image set is the range set of the function, right? So now just see few examples related to the domain and the range. Let's suppose you are given a function of the form sine at x into y, right? Here x and y, these are the real numbers. So we have to see what will be the domain set. Since this function is defined for all values of x and y, so the domain set will be the entire plane. Entire plane means r cross r, right? Set of real numbers cross real numbers. And what is the range set? Since we know that sine theta is lying between -1 and 1, so the range set will be, the image set will be minus 1 to 1. Okay. Now just see one more example. Let's suppose the function is defined in the terms of x square plus y square plus z square square root. Again, it is an entire space. It is defined for all values of x and y and z. So this is R cross R cross R. This is the domain set. And what is the range set over here? Since this square root gives us the positive value, because if it is negative, then it will become the complex. So that is not in this case. So this is the range set, right? Now the next is, what do you mean by the interior point of the set of any set, or you can say of the domain set, right? So now just see what is the interior point of a set. In case of real line, if you see, what are the set in case of real line? They are the intervals or union of intervals, right? So what are the interior points? You take any point from that set and you take a neighborhood around that. Now what is the neighborhood? The points near to this, right? In terms of open one. So if you say x is any point in this interval I, let's suppose this interval is I, then you can say x minus epsilon comma x plus epsilon is an open neighborhood containing the point x where epsilon is very small positive number. So we choose every point near x, right? So these points will become the neighborhood points for the set x, for this point x, right? So if this neighborhood comes out in the terms of interval in case of a real line, right? So this neighborhood, if this neighborhood is completely contained in I, then this x is said to be an interior point of I, right? So x is an interior point of I if we consider any open interval around the point x, very small open interval which is completely contained in the interval I, then this point will become the interior point of I, right? So this point should be completely lie in that set. So it should be the interior one. Okay. So now we can extend it in case of two variables. In case of two variables, we are having a plane. So let's suppose this is any set, domain set D, and this is any point x comma y. So this point x comma y is said to be an interior point of this domain if we consider a neighborhood around this point x comma y. So here the neighborhood will be of the form open disk. All the points lying inside the circle centered at point x comma y with very small radius epsilon, right? So every point lying inside this circle with radius epsilon and center at x comma y, right? So that will become an open disk around the point x comma y. If this open disk is completely contained in the domain set, then this point x comma y is said to be an interior point of the set, right? So when will this point is said to be an interior point? If we consider any open disk around this point and if it is completely lying in the domain, then this point will become the interior point of that set, right? Now what do you mean by the boundary point? Now what is the boundary point? Now again, in case of function of two variables, let's suppose this is any domain set, then the point lying on this boundary, right? Let's suppose this is x comma y, then this x comma y is said to be a boundary point if we consider any open disk around this point with very small radius. It's not completely lying in the domain, right? Its intersection, let's call this open disk as, let's suppose a small open disk with radius epsilon containing centered at x comma y. So if this open disk intersection with the domain is non-empty, as well as intersection with the domain complement, if this is non-empty, then this point, and this is true for every smallest to smallest neighborhood open disk around this point x comma y, if this thing holds, then this point is lying on the boundary, right? Now what do you mean by the complement of a set? If the entire plane, if we have a entire plane, right, and this D is the domain, this D denotes the domain set, this is the whole set, the universal set, then the complement will be R cross R minus the domain set, right? So all the points rest of this domain. So that is a domain complement, right? So this point is said to be the boundary point if you consider any open neighborhood around this point, if its intersection with the domain as well as its domain complement is non-empty, right? Means intersection जो है that is non-empty, means at least one point lying in the intersection. So this point is lying on the boundaries. So this point is the boundary point. For example, let's suppose if we consider a domain set as let's suppose it is a circle which satisfying this equation. All those xy belonging to R such that x square plus y square is less than equal to 1. So what is this domain set? It is a circle with center at 0 and radius 1. So this is our domain set, right? So what are the interior points of this set? So interior points are all those xy belonging to the real numbers such that x square plus y square is strictly less than 1. All the points strictly lying inside this circle are the interior points for this domain, right? What are the boundary points? Those xy belonging to R such that x square plus y square is exactly 1. So the points lying on this line, right, on this circumference of a circle, that these points are the boundary points. Now what are the exterior points? The points which lie outside the domain, that are the exterior points. Means the point which is outside the domain, and when you consider any open disk around this, it is completely contained in the domain complement, right? Or you can say the point which is neither interior nor boundary will become the exterior point of the domain set. So these are interior, boundary points and exterior points of the domain. Now what are the exterior points for this set? The exterior points are x square plus y square strictly greater than 1. So all those xy belonging to real numbers such that x square plus y square is greater than 1 are the exterior points. These are the boundary points. These are the interior points, right? So these are interior, boundary and exterior point. Now the next concept is the boundedness. So when will you say your domain is bounded? If your domain set, or you can say your function, if this is lying between some fixed values, then this function is said to be bounded. For example, in the previous example, let's suppose you are having this domain set, right? So we will see, though this z It contains all those xy, right, belonging to the real numbers which satisfying this condition. So it is the function of all those xy belonging to R such that x square plus y square is less than equal to 1. So clearly it is bounded because all this z is always lying between -1 and +1, right? So this function is bounded. But if you consider this function, is it bounded? No, it's not bounded because we have xy belonging to reals which are strictly greater than 1. They are bounded below but not bounded above. Right? We cannot get a capital M in this case such that this number is strictly less than some number. Right? This does not hold here. So therefore this is not bounded in plane. Okay. Now the next is the definition of a limit. How to define a limit in case of function of more than one variable. Now just recall in a case of function of single variable. Let's suppose you are given a function which is depending on only one independent variable x, and we have to find out the limit at a. So whenever your x tending to a, if your fx, this is approaching to some number L where this L is finite and unique, then you will say the limit exists at x is equal to a, right? So this function has a limit at x is equal to a. So in case of single variable, let's suppose this is your a. So x tending to a means we can approach either from this side or from this side. So in case of single variable, we are having only two directions. One is left hand side direction, so left hand limit. The other is right hand limit. So we will find out the limit x approaching to the left side as well as the limit approaching to the right side. If both these limit exist, both are equal, both are finite and unique, so you will say the function has a limit at x is equal to a. So in case of single variable, we are having only two directions. One is the left and other is the right. But now just see, whenever you are having a function more than one independent variable, so let's suppose we are having a function of two variables x and y, and we have to find out the limit at any point x naught comma y naught of some function, right? So what is the limit in this case? Now we want to find out xy approaching to x naught comma y naught if the function is approaching to some L where this L is finite and unique. You will say this function has a limit at the point x naught comma y naught, right? But here we are not having only two directions, left hand and right hand. Since we can move in all directions, right? We can change a little change in x, then little change in y, so we can move in open disk, right? So we are having infinitely many direction passes through the point x naught comma y naught in case of two variables, in case of a plane, right? Around this point we are having infinitely many directions. Now just see, for example, let's suppose in case of a circle centered at 0 with radius 1, let's suppose 0 0 is a point, right? So what are the path passes through 0 0? There are infinitely many paths. The line y is equal to 0, it passes through 0 0. The line passes through x is equal to 0, this passes through the point 0 comma 0. X is equal to y line, this passes through 0 comma 0. X is equal to 2y, this passes through 0 comma 0. Y is equal to 2x, this passes through 0 comma 0. Similarly, x is equal to minus y, x is equal to minus 2y, and so on. There are infinitely many paths which are passes through the point 0 comma 0. So if in all paths the value of the function is approaching to this unique limit, finite and unique limit, then we will say the function has limit at a point x naught comma y naught, right? But if we get different limits, different values at different paths, then this function does not have the limit at that point x naught comma y naught, right? So in this way we can find out the limit of a function, right? You, in case of a rational function, we just substitute the value of we replace x with x naught and y with y naught. If we get a finite and unique value, then we will say the function has a limit at the point x naught comma y naught. All the rules related to limit function, they are applicable over here. Means if we are having f function, if we are having g function, both these functions has the limit at any point x naught comma y naught. Let's suppose this limit is L1, and here this limit is L2. Then the sum of these two, the difference of these two, multiplication with some k, the multiplication of these two functions, division of these two functions provided the denominator is non-zero. All these functions have the limits in the terms of sum, difference, product, multiplication with the scalar, and division, right? All these rules hold in case of a limit functions of two variables, right? For example, if we need to find out the limit of the function at 0 comma 1, so what will we do here? We just substitute the value of x and y, right? Now just see, when you put x to be 0 and y to be 1, what will you have? We get this limit is minus 3. This is finite and unique, right? So therefore we will say this function has a limit at 0 comma 1, and which is minus 3. So this exists. Let's suppose we have to find out the limit of the function x square minus xy upon square root of x minus square root of y at 0 comma 0. So when you substitute the value of x and y in this function, we will get 0 by 0 form, right? So we cannot put directly. It means at 0 comma 0 this function is not defined, but we cannot say that the limit does not exist at this point. We have to find out the limit. Now just see, we can take x to be common in the numerator, and then we can find out its factors. So we can make the factors over here. Now just see, this term is cancelled out, and now when you substitute the value of x to be 0 and y to be 0, you will get this is 0. So this limit exists, right? So here the limit exists at 0 comma 0. However, our function is not defined at 0, because at 0 0 the function attains the value 0 by 0 form. So it does not passes through 0 comma 0, but the limit exists at 0 comma 0. Now the next, see the continuity. Now what do you mean by continuity in case of a function of more than one variable? So now let's suppose a function is continuous. We will say a function is continuous at any point x naught comma y naught if, first of all, f is defined at x naught comma y naught. The secondly, the limit xy approaching to x naught comma y naught f of xy exists, and the third is the limit xy approaching to x naught comma y naught, this value is same as that the value of the function at x naught comma y naught, then we will say our function is continuous at a point x naught comma y naught. And if it is true for every point of the domain, then this implies the function is continuous function, right? Now just see what is the mean of continuity in case of a function of more than one variable. Now just recall in the case of single variable, what do you mean by function? Continuity in case of a single variable, a function f is said to be continuous at x is equal to a if first of all function should be defined at a, secondly the limit at x approaching to a f of x this should exist, and the third, this limit should be equal to the value of the function at a, right? If this thing hold, you will say your function is continuous in case of a single variable. Basically what does it mean? It means whenever you are approaching to the point from the left side or from the right hand side, the limit of the function exists and it approaches to f of a, right? So whenever this thing holds, you will say your function is continuous at a, right? So whenever we are approaching to a, your x is approaching to a from the left and the right hand side, your fx is approaching to f of a, then you will say your function is continuous at a, means there is no break at a, right? So your function is smooth function, there is no break. So this that means your function is continuous in case of a single variable. Now we can extend it for a function of two variables. The same way your function should be defined at that point, the limit should exist, and the value of the limit is same as that the value of the function at that point. If this thing hold, you will say your function is continuous at x naught comma y naught, and if it is true for every point of the domain, then your function is continuous function. Now just see in the previous example here, this function is not continuous. However, the limit exists at 0. But this function is not continuous. Why? Because your function is not defined at 0. This function is not passes through 0 comma 0. Okay. What we required here for continuity, we required this should be equal to f0 comma 0. But here at 0 comma 0, your function is of the form 0 by 0. It is not defined. So this function is not continuous at 0 comma 0. But if we consider the function to be as this, when your xy is non-zero and at xy comma 0 comma 0, if your function is 0, now it becomes equal. The limit exists at this point. The value of the limit is same as that the value of the function at 0. Now this function is continuous function. So this function is continuous at 0 comma 0 and rest all other points, right? But if you not consider this condition, then only limit exists at 0 comma 0. However, your function is not continuous at 0 comma 0. Just see more examples related to continuity. E to the power x minus y, it's a function of two variables x and y. This function is always continuous for every point of the domain. Right? Why this function is continuous? Because it is defined for all values of real numbers, right? And we know that exponential function is always continuous. So e to the power x is continuous, e to the power y minus y is continuous, and the product of two continuous function is again continuous function. The same way, let's suppose you are having a function of the form cos of x into y upon x square plus 1. Now just see, since we know that cos theta, this is always continuous for every theta, and x into y upon x square plus y, this function is defined for all values of x and y belonging to real numbers, right? So this function is defined for all x, y. This function is continuous also. So again, the composition of these two functions. So Composition of continuous function is again continuous. So this function is continuous function, right? Now the next type of question is here that the function is not continuous at some point. So for example, show that the f of xy is 2xy upon x square plus y square whenever your xy is not equal to 0 comma 0, and it is 0 whenever your xy is 0. So we have to show that this function is continuous at every point except at origin. Now just see the solution. Now just see, whenever your point is not 0 comma 0, this is a rational function. A polynomial divided by polynomial, this is continuous, this is continuous. The division of two continuous function is again continuous provided this is non-zero. So here it is non-zero because your xy they are non-zero. So this is continuous function for all xy belonging to the real except 0 comma 0. So clearly this function is continuous function. Now see, whenever your xy is approaching to 0 comma 0, what will happen? So when you find out the limit your xy approaching to 0 comma 0 of the function 2xy upon x square plus y square. So now just see, there are infinitely many path passes through this 0 comma 0. So if we choose a path y is equal to mx, then clearly whenever your x is approaching to 0, this implies y is also approaching to 0. It means this y is equal to mx path is passing through 0 comma 0, right? So if we choose this path, then we can convert this limit into a function of single variable by substituting y to be mx. So when you put y to be mx, what you get, this term is cancelled out in the numerator and denominator. What is this limit? When you take x tending to 0, you will get this is 2m upon 1 plus m square. So it depends on m. It is not unique. It's not unique. Now why it is not unique? Now just see, if you consider y is equal to 0 path, means your m is 0. What will be the limit? In that case the limit is 0. We'll put m to be 0, you will get 0, right? So when you consider y is equal to x path, means your m is 1. What will be the limit? In that case the limit is 2 upon 1 plus 1, 2, which is 2 by 2, which is 1, right? So this path is passing through 0 comma 0, this path is passing through 0 comma 0, but the limit is not same. Here the limit is 0, here the limit is 1, means it depends on m, it is not unique. Now since the limit is not unique, so at 0 comma 0 the limit does not exist, means your function is not continuous at origin. Okay, so what will you write? By two path test, the limit of the given function does not exist at 0 comma 0, Therefore, the function is not continuous at 0, comma 0. Now, what is this two-path test for non-existence of limit? Two-path test means we have to find out the limit of the function at two different paths passes through the same point. If this limit is not unique, implies limit does not exist, right? Means we will find out the limit at two different paths passes through the same point. If this value is not same, you will say limit does not exist. So this test is said to be two path test. For example, here, so here we will see when you put m to be 0, you will have the different limit. At x it is different. So these limits are not same with two different paths passes through the same point 0, 0. So this implies that by two-part test the limit does not exist at 0, 0. So now just see with help of one more example. So the next question is how to choose this path, right? So how to choose this path? For example, let's suppose we have to show that the function f of xy is equal to 2x square y upon x to the power 4 plus y square. This has no limit as x comma y approaches 0, 0. Now just see the solution. We need to check at 0, 0. So we need to find out those paths which are passes through 0, 0 such that the terms in x and y in the numerator are cancelled out with the terms in x and y in the denominator. So we have to choose a path in such a way so that x, y terms are cancelled out in the numerator as well as in the denominator, and that path is also passed through 0, 0. Now just see here, you are having x square into y. Here you are having x to the power 4 in plus y square. So if we choose y to be mx square, you will see the degree of x square in the numerator is 4 as well as in the denominator is 4. So that will be cancelled out. So if we choose the path y is equal to mx square, clearly this path is passes through 0, 0. When you put x to 0, your y is also tending to 0. So this path is passed through 0, 0. So if we choose this path and find out the limit as xy approaching to 0, 0 of this function, this will be converting into single variable x tending to 0 by substituting this. So we will see this x to the power 4 will be cancelled out in the numerator and denominator, and again it depends on m. Now since it depends on m, so this implies not unique. The value of this limit is not unique. When you put m to be 0, it is 0. When you put m to be 1, it is 1. When you put m to be 2, it's different. So at every different path, you are having different limits. All these paths are passes through the same point 0, 0. So since this limit is not unique, so by two path test, what will we get? We get the limit of the given function does not exist at 0, 0.